Hello guys, welcome back to Mathematics class with me, Ma'am Ruth. So today we will learn about trigonometric formula part 2. So what is it about? Let's check it here. We will learn trigonometric formula of double angle for sine, cosine, and also tangent. So before that, we will review first our formula of compound angle. You still remember how many formula that we already finished? Yes, it is 6 formula. The first one is for sine alpha plus beta, which is sine cos plus cosine. Sine alpha minus beta, sine cos minus cosine. Cos alpha plus beta, cos cos minus sine sine. And cos alpha minus beta is cos cos plus sine sine. 2 more is the formula of compound angle for tangent. First, tangent alpha plus beta equals tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. And for tangent alpha minus beta, it is tangent alpha minus tangent beta over 1 plus tangent alpha plus tangent beta. You already can see how the sign is related, right? So, better to remember all before we have more formulas later. So, for today's formula, we will prove that sine 2x equal to sine x cos x. So this is double angle that you can check. You can upgrade x become 2x. First, how to prove it? We will take it again, the formula of sine alpha plus beta, which is sine alpha cos beta plus cos alpha sine beta. Next, we will change alpha and beta with x. So we have sine x plus x equals sine x cos x plus cos x sine x. X plus x become 2x, and you can see that sine cos and cosine is the same term. You can rearrange and join them together, so we have sine 2x equal to sine x cos x. Next, we will prove that cos 2x equal cos square x minus sine square x. So this is the double angle for cos part. First, the same with previous, we will use the cos alpha plus beta and change it become x. So we have cos x minus sine x, and we can join them together, become cos 2x equal cos square x minus sine square x. So this is how we derive the formula of double angle for cos. Next, the cos 2x also can be described using 2 cos square x minus 1 and 1 minus 2 sine square x. Okay, so let's do it together to prove that this can be described like this. Are you ready? So, let's start from the formula of cos 2x. You still remember? Cos 2x is cos square x minus sine square x. Next, we also will recall the formula of identity that we have here. We have sine square x plus cos square x equals 1, so that we can change sine square become 1 minus cos square x. Now, we will substitute sine square like this, and we just need to collect the cos square together. Cos square minus cos square become 2 cos square x, and we have minus 1. So this is proven. Next, for the other formula, we will have cos 2x again, which is cos square x minus sine square x. The identity formula will be changed, become cos square x equal 1 minus sine square x. So we just need to substitute that cos square is 1 minus sine square, and then collect the sine square together. So do you get the same result? Good job. Let's go to the next example. After finishing example 1, we continue to example 2. Calculate cos 67.5 degree without using calculator. Okay, this one as well, let's do it together. For cos 67.5, please recall that 67.5 is a half times any special angle 135, right? So we have to find out any connection between the value that we need to find with any special angle that we know. So we will using the formula of cos 2x. If cos 2x equal, you can choose which one from the cos 2x. Since here we need cos 67.5, then we will use 1 minus, so we will use 2 cos square x minus 1. So we can substitute 2x with 135, so that the value of cos x will be changed become 67.5. Then, what is the value of cos 135? Remember, the basic angle alpha is 45 degree, and this is angle in quadrant 2. So, we have the value of cos 135 minus a half square root of 2. Next, we will find out cos square 67.5, which is 1 minus a half square root of 2 over 2. Then, the value of cos 67.5 become square root of, so now it can be simplified, become yes, now you got your first diamond point. Let's continue until the end and have some more diamond points. Now we have example 3. Write cos 3x in terms of cos x. Let's get started. Okay, we solve example 3 like this. We separate cos 3x become 2x plus x, and we use cos alpha plus beta, which is cos alpha, here alpha is 2x, cos beta minus sin alpha, sin beta. After this, we will make all of the angle become in x. Use double angle formula. So the double angle formula is applied for cos 2x and sin 2x. Now we just need to simplify like this, but we don't want the sin square. So change sin square become cos square, and then rearrange. So now we will derive the tangent to x formula. First, we will use again tangent of compound angle alpha plus beta, which is tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. And then we substitute alpha and beta with x, so that we have tangent x plus x equal tangent x plus tangent x over 1 minus tangent x times tangent x. Since here we can simplify it become tangent to x, so we can have the formula 2 tangent x over 1 minus tangent square x. Yeah, that is our second diamond points. So let's continue until the end and get all of them together. Here we have example 4. Given that tangent x equals minus 4 over 3, which x between 270 degree and 360 degree, calculate the value of cos 2x and then sine 4x. So let's see the working together. So this is the answer for example 4. Tangent x equals minus 4 over 3. Here it lies on what quadrant is this? This is quadrant 4. So later we need to calculate the ratio of cos 2x and then sine 4x. So we start with drawing the right angle triangle here with the ratio of opposite, which is 4, and adjacent, which is 3. And then, since it is in quadrant 4, we also have to know that here at the quadrant 4, cos will be positive, where sine and tangent is negative. Then, for the value of sine x here, it is opposite, which is 4 over 5. And since it is at the fourth quadrant, we add the negative sign. And for the value of cos x, it is adjacent over hypotenuse and the sign is positive. Next, we will solve the cos 2x. Cos 2x will be, you can choose one of the two formula available, which is 2 cos square x minus 1, which I use here, or the other formula 1 minus 2 sine square x. Here, if it is cos 2x and 2 cos square x minus 1, so I can substitute cos x 3 over 5 square here minus 1, so it become 18 over 25 minus 1, so the result is minus 7 over 25. Next, we will solve the b part for sine 4x. Here we have the formula of sine 2x, which is 2 sine x cos x. So now, when you have 4x, it means you change this become 4x, then these two terms will be a half of it, right? So we can change it become 2x and 2x. That means here we have 2 sine 2x cos 2x. But what we have at the ratio is sine x and cos x. So now we have to change all of them in terms of x. For sine 2x, I use again the formula of double angle 2 sine x cos x. And for cos 2x, since I counted earlier, I can just substitute it later. So it becomes 4 times sine x is minus 4 over 5, cos x is 3 over 5, and cos 2x is minus 7 over 25. So if you calculate it slowly, you will get the result is 336 over 625. So that's the answer for sine 4x. Now we have the last example about proving identity. Let's prove this following identity. Sine 2x equals 2 tangent x over 1 plus tangent square x. Let's do example 5. To prove the identity, you need to change the left hand side or the right hand side. So usually you can choose the more complex one. I will try to change the right hand side and make it all become sine and cos. Now I will multiply all by cos square to eliminate the denominator, so the result become like this. Next, we know that the denominator is the formula for sine 2x. And at the numerator part, we have cos square plus sine square, which is 1. So then, I can prove it that the identity is the same. So, that is our third diamond point. So, it means we finished the lesson and got all of them together. Thank you for watching this video until the end. We will meet again at the next lesson. Keep healthy, stay safe, see you soon, and bye-bye.